Hello my dear friends, I am Sujoy and I am back with a new series of tutorials for you where I am telling you how to do project management using network analysis. Well, this is my 13th video in the series. In my previous 12 videos, I have explained the project management from the very basic. I have explained some basic definitions regarding project management, how to draw a network diagram, then how to optimize the network diagram using dummy activity, then my 3 videos on critical path method or CPM, and my 2 videos on program evaluation and review technique on PART. I have also talked about multiple critical paths throughout the network, so please do watch my previous videos. Link to all of my previous videos is given in the video description below. So today we will learn how to optimize the project time and project cost by activity crashing. First, in the question, a table like this is given and a network diagram is given. So first look at the table. There are 4 columns. Number 1 is activity column where all the activities starting from activity A ending activity I is given. Next is the predecessor activity. Predecessor activity means an activity which must be completed before another activity can start. For example, activity A must be completed before activity C can start. That is the meaning of predecessor activity. Next we have normal duration and normal cost. Our unit for time is day and unit for cost is rupees. So 2 for duration means activity A takes 2 days to complete and it takes 200 rupees to complete in 2 days in normal scenario. Next is crash duration and crash cost. The crash duration represents the minimum time an activity can be completed with extra resource or extra money. So activity A can be completed in 1 day instead of 2 days but at increased cost of 300 rupees per day. In normal duration it takes 200 rupees for 2 days. So that means 100 rupees per day, but in crash situation or in shortened situation it takes 300 rupees per day, that is 3 times. So although we can reduce the activity duration, but our project cost will increase. So we have to do little bit calculation to find out the optimum project duration and optimum project cost, in which we can reduce our project duration with least increase in project cost. That relation we have to find out. Next thing, look at this value. This value is the summation of all normal cost values. And this value is called the direct cost of project. We will use this value in our calculations. Next, look at the network diagram. We have one critical path, that is B, D, G and I via the events 1, 3, 5, 7 and 8. So for our critical path B, D, G, I, our total time duration value is 26 days. Now we will check whether we can reduce the time duration value with least possible increase in our project cost. So remember, the project duration depends on the critical path, or it depends on the duration of critical activities. So if you want to reduce the project duration, then we have to reduce the individual time duration value for each critical activity. So here critical activities are B, D, G, I along the critical path. Our next question is how to determine which critical activity to reduce first. For that we will use a simple formula. We will find out the cost slope value for each critical activity. So let us do the calculations. First, the indirect cost, which is given in the question, which is 100 rupees per day. Next we will find out the direct cost, which is rupees 4500. That is the sum of all normal cost of the project. So the total cost is equals to direct cost plus the indirect cost. That's equals to 4500 plus indirect cost is rupees 100 per day, and our default project duration is 26 days. So it will become 26 into 100 plus 4500. So our total project cost as of now is rupees 7100. So we will try to reduce it. Step number 1. To reduce the project duration, we need to reduce time duration of individual critical activities. So first we will find out the slope value for each critical activity. Slope value is given by this formula. and reduce or crash that activity first which has the minimum slope value. So first let us find out the slope value for our 4 critical activities B, D, G and I. So for B, the slope value is given by crash cost, that is 300, minus the normal cost, that is again 300, divided by the normal duration, that is 2, minus the crash duration, that is again 2. So it becomes 300 minus 300 divided by 2 minus 2. So 300 minus 300 is 0 and 0 divided by anything is 0. So for activity B, the slope becomes 0. So we will make a chart like this in which we will write down all the critical activities. Next we will write down all the possible reduction for that activity, and next we will write down the slope value. The possible reduction value is equals to normal duration minus the crash duration. So for activity B, the possible value is 2 minus 2, 0. That means there is no reduction in time is possible for activity B. Next, for activity D, the slope value is given by crash cost, that is 600, minus normal cost, that is 500, divided by normal duration 8 minus crash duration 6. So that becomes 100 divided by 2 is 50. So for activity D, the slope value is 50 and the possible value is 2, that is normal duration 8 minus crash duration 6. So we'll start with the activity which has the minimum slope value. So for us, which is B, with minimum slope value 0, but the possibility is also 0. But the activity B is at its crash duration, that is 2. So no further reduction is possible. So we reduce crash the activity with the next minimum slope value, which is activity D, and 2 days reduction is possible with increased cost of rupees 50 per day. So we will reduce activity D from 8 days to 7 days, and the project duration will reduce from 26 days to 25 days, and the total cost will become direct cost plus the crashing cost for crashing and indirect cost for 25 days. So it will become direct cost 4500 plus crashing cost rupees 50 per day for 1 day plus the indirect cost for 25 days. So it will become 7050. So we can see we have reduced the project cost by 50 rupees in our first step. Step number 2. Next we will check that due to the crashing any new activity has become critical or not. That is, any new critical path has formed or not. If a new critical path has formed, we need to reduce the total duration of each critical path simultaneously. What that means? We have reduced the activity D from its current duration 8 days to 7 days. And let's check the paths throughout the network. So for the path A, C, F and I, the total duration is 2 plus 3 5 plus 3 8 plus 9 17. For path B, D, G, I, it is now 2 plus 7 9 plus 7 16 plus 9 25. And next path B, E, H and I, for which the total duration is 2 plus 5 7 plus 2 9 plus 9 18. So as of now, the total duration value for path BDGI is 25, which is maximum. And as we know, path which has the maximum time duration value is the critical path. So as of now, our critical path is BDGI, which is not changed. In some question, after doing any crashing, a new critical path may be formed. So we may get 2 parallel critical paths throughout the network. In that case, we have to reduce the time duration for each critical path simultaneously. We have 2 reductions possible for activity D. We have reduced only one from 8 to 7. Now we reduce it from 7 to 6. So step number 3, we will reduce activity D from 7 days to 6 days, and the project duration will reduce to 25 minus 1, 24 days. So the total cost will become direct cost plus caching cost plus indirect cost for 24 days. That's equals to 4500 direct cost plus crashing cost rupees 50 per day for 1 day plus 24 into 100, that's equals to 6950. So again we have reduced the project cost by 100 rupees in our third step. Remember, after each crashing activity we have to check for critical paths. Step number 4. Now activity D as its crash duration. So no further reduction is possible because it is right now at 6, which is its crash duration. So we reduce the activity with next minimum slope value. So the activity with next minimum slope value is activity G with slope value 100 and possible reduction of 2 days. So which is activity G, and 2 days reduction is possible with increased cost of rupees 100 per day, which is slope value. So if we reduce the activity G from 7 days to 6 days, the project duration will reduce by 1 day. It will become 23 days. So the total cost becomes direct cost plus crashing cost plus indirect cost for 23 days. So direct cost is fixed 4500 plus crashing cost is now 100 rupees per day for activity G, and indirect cost is rupees 100 into 23. So our total cost becomes 6900. So again we have reduced our project cost by rupees 50 in our fourth step. Step 5. Again we reduce G from 6 days to 5 days. Project duration reduced to 22 days, and the total cost will become 4500 plus 100 into 1 plus 22 into 100. That's equal to 6800. So we have reduced the project cost again by 100 rupees in our fifth step. Step 6. Now activity G at its crash duration. So no further reduction is possible. So we reduce the activity with next minimum slope value, which is activity I with slope value 150, and possible reduction is 2 days. So which is activity I, and 2 days reduction is possible with increased cost of rupees 150 per day. So if we reduce I from 9 days to 8 days, the project duration will reduce to 21 days. So total cost will become 4500 plus crashing cost of rupees 150 per day for 1 day plus indirect cost for 21 days. So that will become 6750. So we have reduced the project cost by 50 rupees in our sixth step. Step 7. Again we reduce activity I from 8 days to 7 days, and project duration reduced to 20 days. So total cost will become 4500 plus crashing cost of rupees 150 plus indirect cost for 20 days. That's equal to 6650. Step 8. Now all critical activities P, D, G and I are at their crash duration. Activity D is reduced to 6 days from its normal duration of 8 days. Activity G is reduced to 5 days from its normal duration of 7 days. And activity I is reduced to 7 days from its normal duration of 9 days. So since all the critical activities are at their crash durations, no further reduction is possible. So we have reached at our optimal duration point and no other critical path is available. In some question, after doing all the crashings, you may get another critical path. We have to consider the cost of that path also. But for our question, there is only one critical path, so our calculation is done. Hence, the minimum project duration is 20 days with associated cost of rupees 6650 along the critical path BDGI. Now comparing it with the initial situation, we have reduced the project duration from 26 days to 20 days, and we have reduced our project cost from 7100 rupees to 6650 rupees. Now one note for you. Generally, when we reduce the project duration, the total cost increases. But in our question, we were successful in reducing both the duration and the cost, which is an exception. And that's why I have taken this question for you. But in other questions, when you reduce the project duration, you can see the project cost is increasing. So nothing to worry about that. So friends, this was the end of the video. How was the video? Let me know in the comments below. I will upload more videos in the series. So don't forget to subscribe to my YouTube channel so that when I upload my next video, you get an email if you subscribe. And please appreciate my hard work by liking and sharing the video, because sharing is caring. I have uploaded videos on statistics, numerical methods, business and financial mathematics, operations research, computer science and engineering, electrical engineering, Android app reviews, India travel and tourism, street foods and life hack videos, and a series of videos showing how to use your scientific calculators, Casio FX991 ES and FX82 MS to do maths easily. You can get all my videos on my YouTube channel. The link is www.youtube.com/sujoyn70. So thanks for watching. See you in my next video, and still then stay connected by subscribing.